right? So any project, if you can just put it in that framework, it will be good. Okay. Then remember alternatives to Fluid, like CRISP methodology, or SEMMA, or Canva, or TDSP by Microsoft. Microsoft has the best documentation when you're looking at some of these process frameworks. If you go to Google and type Microsoft TDSP, it will take you to the documentation. The documentation when it comes to Microsoft is really, really very detailed, beautiful. Anybody can read and go through and understand it. You can't have better documentation than Microsoft about that, right? They have a nice, see in Fluid, you have a benzene ring. They have just put it like 4 circles, data pre-processing, and they've just ended it. Right, so this is basically a process framework, which tells you step by step what you do, right? Any one idea from each of these things, if you can just highlight.
I think first is collaboration.
Yeah.
Where we connect with stakeholder and try to understand the business.
Yes.
Then is when the problem.
So first let's focus on collaboration itself. So usually when you talk about collaboration, what exactly do we have in mind? Multiple stakeholders, because any analytical solution will affect multiple people. So board all of their concerns, be in touch with everybody. That's what we are saying, nothing else. Right? So this is the first stage wherein we will be looking at collaborating with the stakeholders, correct? The stakeholders could be the database guy, and why do you need to collaborate with him? Because he's the one who's going to give you the data, right? So without data, we can't do any analysis. Secondly, basically the top management who will give you the buy-in. Secondly, thirdly, basically you may have the data science team at the onshore side. They themselves might be building some models. So you have to either give them higher accuracy or better predictive model, better ROI. Only then they will basically adopt your methodology. Otherwise, some outsider is coming, he's talking about some this thing, fancy terminologies, why should he give, correct? So this is the reason as to why you need to collaborate with multiple people. Second stage in Fluid is, yeah, very, very important. What are you doing here?
Define the KPIs.
Exactly, defining the business objectives, right? And a business objective will be in a business man's language, right? Build a supervised machine learning technique. That is not a business objective. Increase the profit, yes. Bring down the cost, yes. Right? Decrease the FTEs, yes. Right? Either it is resource management or cost optimization or revenue increase. These are some of the problems that we are trying to tackle. That should be clearly mentioned. To what extent? You can't say 30%, 40% upfront. That is, no model will be able to. 3%, 4% incrementally, we can always do that. Capturing, is it? But I don't know whether it is capturing properly.
It charges almost 95%.
Okay.
It's not intelligent.
It's also NLP.
Speech to text. I have no problem either ways. I'm okay with any way. Okay. Will that be a distraction later to you? I don't know. Yeah, when you see it. Okay, so building phase is clear. Third stage is basically
Collation.
Yeah, collation. Collation is important. Why?
Resource and features.
Collect all the features or the variables that you think will help you solve the business problem that you have set in the second step. There's a sequence, correct? So you are at this stage collating. Collate means basically collect all the features which are necessary. Over a period of time, right now, since you are taking baby steps in this world of data science, you may be thrilled and excited with the algorithms, right? I have learned neural network. Next day, support vector machine. Third day, something else. Fourth day, reinforcement learning. You'll always have that curiosity, something new, something fancy I'm learning. But over a period of time, 2 or 3 years down the line, you will see it is not so much the algorithm. It is the domain and the domain expertise which will win over the algorithms. You may use an excellent deep learning technique. It may give you rubbish results, it's not usable at all. Correct? On the other hand, from the existing variables, right? If I can derive new features from the existing raw data, right? What do we say usually? If this model does not work, change the model. That does not work, change to another model. Decision tree does not work, change to another model. That is not really an effective procedure in real time scenario. Because you may not see a big or a drastic result. Where your expertise will be valued is from the raw data, if you can derive new meaningful features. You have debt of the customer, you have income. If you feed these as it is, you may not get good value, you may not get any high accuracy. But usually, if you just take a simple ratio, debt to income ratio, that variable will drive the outcome variable much better than the individual variables. Simple. Correct? Many times, when you're talking about drug response of a patient to a particular drug, sodium content in the blood is given. Potassium content in the blood is given. If you work on both these variables individually, nothing good will come out. But a simple ratio of these variables, sodium to potassium ratio in the blood, then you start seeing the data starts talking to you. Which drug? I have one case study, beautiful case study, right? When we work on the individual variables, nothing is, you will not be excited at all, right? But just take a simple ratio that is called as feature engineering. It can be a simple ratio, it can be a simple percentage, it could be anything else. But the moment you start playing around with these variables, they tend to have a big impact on the overall accuracy and such things. So feature engineering. And how do these ideas come into picture? White paper, start reading white papers in that particular field. If you are saying that if somebody says, sir, my area of expertise, I've chosen image analysis as my expertise. 8 to 10 months you spend just in image analytics. If you say that, sir, speech analytics is my forte, I want to make a career for myself in text analytics or speech analytics, just go in depth in that area itself. You don't, otherwise you'll be jack of all, master of none. One area you select and keep working on that itself as much as possible, so that your confidence in that area becomes more and more. When I say work on that, all the algorithms, what are the pitfalls or the disadvantages of the algorithm, what are some of the white papers that you can quote, then you will become a real expert. Otherwise, why do people mostly fail to clear an interview? Because 3 days they would have worked on NLP, 4th day they'll do some image processing, 5th day they'll talk about transfer learning, 6th day they'll come to probability and statistics. So it will become a big chow chow. You will never be good at anything in that sense. So make up your mind, sir. NLP is very exciting. If you say go in depth, and to when I say go in depth, it may take around 10 months for you to master it. Right? If you say, sir, NLP is not my cup of tea, I like machine learning. Go in depth of machine learning itself. If you say, sir, I want to be a cloud architect, right? Try to read inside out about cloud architecture itself. If you say deep learning and AI, of course you are into AI, you have to learn about AI. One particular area, recommendation system. A recommendation system in e-commerce. Try to be an expert in recommender system. Recommendation system, very exciting field. Otherwise, what happens is that one project on a recommendation system that is not good enough, second project on something else, you will just know enough to confuse people, but certainly you will not know enough to convince people. That's the biggest reason as to why people do not clear an interview. I have to teach. In the sense here in RACE, we give you, machine learning 1 month, next database management system, next reinforcement learning, next, right? We try to give you everything, but you can pick, go through everything, go through all of these things. But one area which appeals to you, you pick up that and try to master. That's what I'm saying. Okay. Now, if fluid is now once you start mastering it, that's when this feature engineering. How do I engineer? How do I manufacture new variables? These ideas will start coming. These ideas will start coming to you. You know, how do I, from the existing data, it does not work. How do I play around with the variables, create my own meaningful variables? That is where your brain and such things will be really tested and you will be valued. Okay. So far it's clear. Now feature engineering will come to you. Otherwise, if you're seeing the data itself first time you're seeing, you'll go blank, right? You will not be able to create new features, derive new columns and such things, right? That idea itself will not come to your mind. Okay, so feature engineering. After that, once I feel comfortable that I have sufficient number of features, then what do? I move on to any of the analytical solution. Analytical solution is what? You can simply do a few charts, dashboarding and such things. Right? No prediction. Everybody does not need prediction. Simply, you can just do a few tables and a few graphs. Your job is done. If the requirement is such that, right, I need to do a few graphs, I'll do that. Right? So dashboards and such things are fine. Next is many times hypothesis testing. Business has certain hypotheses and such things which I need to test. I will do some testing of hypothesis. That is where day 2 becomes important to you. T-test, A/B testing, benchmark analysis, before and after, ANOVA, all those things, whatever we did, that becomes important. Correlation, all those things become important, right? Or else if you say, I want to build a model, you can go. These are the 3 weapons that you use.
ANOVA is only like when there are multiple combination we make.
When you are comparing more than 2 groups, use ANOVA.
Otherwise, only
T-test, independent samples, T-test or independent. Okay, so far we are clear. Right, so this is your model. Then if the model is usable, right, you will deploy it, or else you will revise the model, you will recalibrate the model or change the model itself. Nothing moves. Either within the model itself, I can adjust certain parameters, tweak the model slightly. So that is not working. If that does not work, change the model, build a fresh model. It's a completely different. Before it sees the light of the day. Because once it goes to the production environment, it is outside my hand. I can't do anything. Right? Till such time as it is within my control, I can play around and tweak it, change it, I can do everything. Once it is outside my control, I'm dead. Dead in the sense it is on autopilot mode, it is going on, right? And the last stage is basically capitalized stage. We are talking about capitalization. What do I mean by capitalization? See, people basically, we all are in a way part of data science community, right? What excites us is maybe Gini's quotient, entropy, R square, MSC. This is a language that we speak. But the top level, they understand only one language, which is the language of vitamin N2. How much you do, whatever circus you want, what is the benefit of this? Benefit means basically you have to tie it to a return on investment. What is the yield? How much of cost saving and such. So these are basically the end user, right? To the end user, you should always talk in terms of money. So by doing this, you will be having 5% less cost. You will be able to maximize your profit. You will be able to do cost saving. Your return on investment will be higher. That is the only language which they understand. They don't care a damn whether it is your supervised learning technique, unsupervised learning technique, log transformation or lag transformation or any other transformation. Why do I care? I don't care anything. How much? Because that is what basically makes their ears prick up. So convert this into some monetary benefit, then people will be more inclined to listen to you and adopt your analytical solution.
we don't say in terms of times, this much. Change the time also.
You can talk in terms of time also. See that usually if you're saying that, let me just give you an example. Let us say by building a particular model, you are able to bring about 60 hours of saving. That is fine. But that 60 hours of saving, if you convert it into dollars, it will have a bigger impact. Because I remember I did a project, Kaizen project.
That's why I'm
Fantastic,
saying.
yes. So there, we automated the entire EDA. Right, fine. We were able to say that 5 days of work we were able to save. So which means in a day we work for 8 hours. 8 into 5 is 40 hours. That is not so exciting. Per day, what is the amount that the client is paying? Right, we had some dollar or pound, whatever. We multiplied it by 40 and we got the dollar savings. So we are saying that earlier this is what you used to pay. Now by adopting this, this is how much you will pay. The difference is basically the output of your automation.
That's what because I have done a Kaizen project and like created a dashboard to they are using Excel and doing it. So I have shown there to like this much of hour saves per day.
Yes. Convert this into dollars. Dollars. This is then people will take you seriously. Your profile and your outlook itself will be different because you're no longer a cog in the wheel. The problem with all of our technical people, including me, is that we talk technical language. We don't know how to talk business language. I don't know if some of you are, into hardcore business, but we are mostly into programming, numbers, and such things. But the moment you talk in terms of business language, that's when people will, actually value our efforts. This is the right. You move higher up. Exactly. People will take you seriously. Otherwise, you're just a Java programmer. You're a Python, you're into Python programming. You're an analyst. You'll just be in that circle. Right, the top level, in each level, it is about savings, cost, profit. These are the 3 or 5 metrics which basically they're interested in, nothing else. I'm not interested in anything else. And a lot even people, most of the times, they don't even understand. Who will understand all this Gini's coefficient and such things? Yes, maybe because you're reading and such things, maybe you may have some idea. Otherwise, who understands? Okay, they say and so. Right, so that capitalization part is important because any analytics solution or project, if you build at the end of the day, just 2 sentences. Because by doing this, by implementing this, this is the saving that you'll be making. If not, it's your waste. It's your loss. If you can just say that, there is nothing yet. Okay, this is fluid. Second day, what did we do? Basically, we spoke about testing, correct? Any important highlights that you'd like to say? I would encourage you to speak rather than me speaking. Fantastic. Relationship between 2 categorical variables, chi-square. One headache is over, right? If you can just think of the opposite. Instead of categorical variables, I give you scale variables. What will you do? Fantastic. For categorical variables, use chi-square. For correlation, sorry, for scale variables, use correlation. One example can you give?
Like correlation with length and breadth.
Very good. Length, breadth, height, temperature, price, sales, right? You can just that Boston housing heat map, that itself you can give as an example. Price we had, crime rate we had so many good variables, distance, right? It's a meaningful example that you can give. Correct? For chi-square?
Gender. As we compare
Propensity to respond, whether a person will respond or not, marital status and all your demographic details, usually, not all, but some of them at least, gender, marital status, your income category, right? What is its relationship with whether you'll respond to a campaign or not? Correct? Response to a campaign is what? Yes or no. Right? Whether you're a good credit rating or bad, there's again binary. So when you have 2 categorical variables, you can use chi-square. Right? So one set of problems is over. The second set of problems are what?
have a benchmark.
So when does that come into picture? For comparing means. 3 types. Which are the 3 types? Benchmark analysis. First is benchmark. And A/B testing. Right? Remember the stories. Right? See, many times you'll find concepts very hard, right? If somebody talks about neural network or anything, you'll find it hard. Why? In general.
It's a theoretical. If you end up with the story,
See, at the end of the day, human mind can understand only two things, right? Either you can understand stories or you can understand and process images. Human mind, any human mind, we can understand images, right? Image, this is the image, pictures we can understand. But the problem with data science is that we don't have any images. It's just boring, dull mathematics. Maximize this, minimize this, optimization. That's the reason why sometimes it becomes hard. Convert that into a story, you will be able to relate to the concepts. So any concept, you will not be able to understand any technique. Pick up the story behind it. Right? My CEO once said the same thing. When I was initially struggling, there are so many techniques and it was so, I used to get mixed up. Linear is there, non-linear is there, logistic regression is there, output will come, which data set, when to use. It's a big mess. So I had a boss by name Sumit Varda. He's he is the person who acquired SPSS. SPSS is a software, right? So in 99, basically, he's a person, he was working for IBM, he acquired SPSS and he started distributing SPSS all over India. Right now in 2010 or something, IBM acquired SPSS. Right. So what he's done is basically he started his own company, separate company, wherein using Python and such things, he has come up with his own product. But he used to always tell me, whenever you never run behind equations and such things, always pick up the story behind the technique. Story in the sense, when do I use, when do I not use, right? How do you remember this t-test? Never go after A/B testing, benchmark, you'll forget it within 2 minutes, 2 days. What? Exactly. 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 That is the story you should always keep in. You will never forget t-test. Right? Before tuitions, after tuitions. One set of comparison. Child's marks with the class average. Benchmark analysis. Last is basically the neighbor, right? A/B testing. Right? If there are multiple children, basically it's an order. 3 children's marks I'm comparing, right? Neighbor's kid, right? My house's kid, and my again one more neighbor's kid. 3 groups are there, 3 children are there, right? Let's say Rhea, I don't know, I'm just picking up some Rinki and some Preeti, some names I'm just picking. You are comparing 3 people, right? She has got 60, this person has got 58, that person has got 53, correct? Now 60 is different from 58. Why do you need statistics for that? If a child has got 60, one child has got 60, let's say Rhea has got 60 and Preeti has got 58 and the third child Rinki has got 62. Of course, 58 is different from 60, 60 is different from 62. It is different. Then why do I need an ANOVA? See, p-value, why do I need all these things? The simple answer that you can say is basically, when we are, see, these 3 kids might have taken the examination once. So it is just based on that one-time comparison, fine. Don't need p-value, don't need statistics. Tomorrow, accidentally, if you give another paper, do you think the marks will still hold good? You're measuring their competence in mathematics at an overall level, right? So 3 groups, right? You are actually, when you're assessing this comparison and you don't want the results to be sample dependent, right? That is when the p-value idea concept comes into picture. P is compared with level of significance. If it is smaller, it favors rejection of null hypothesis. If it is greater, it favors acceptance of null. 0.05 is called as level of significance. It is the margin of uncertainty in my decision making. You don't need a statistics.
Then within these 3 sets of data, you
Yes.
multiple samples. That is only one.
So the back end, you can, from that one sample itself, you can generate multiple samples, right?
That is okay.
But I can't manually show it. So far it is clear?
Yes.
Shashikala, sorry. Admit. Morning, madam. Can you hear me, madam? Are you able to hear me, madam? Not sure whether you're able to hear me. Can you hear me, madam? Are you able to hear me? I think you have muted yourself, madam. Madam, you have muted yourself. Amin has not come today. Ashutosh, can you speak of something? Can you unmute yourself and speak something, Ashutosh? He left. Oh, he's there.
Hello, hello.
Yeah. Okay. Madam, I was just saying that you have not missed much. We are just recapping. So, yeah, we have just recap. Okay, day 2 is clear. Hypothesis testing, right? To add color, right? You can just put a few box plot and such things, part of your ADA, bar plot and such things, right? Day 3, we did something which is the foundation of all your machine learning AI model, which is linear regression. Right? Does somebody want to talk about linear regression? When do I use linear regression? What is linear regression? It means what? Be very specific.
We can use it when the variable is scalar. We can use
See, scale is different, scalar is different. Scalar in the sense what value, correct? When the dependent variable is numerical, that is the right. When you say it, it can be also independent variable. So be very specific when you say that I am going to use linear regression when my dependent variable is a scale variable or a numerical variable. It cannot be a categorical variable. Right? Any example? Classic example in the industry is basically prediction of sales, prediction of price, prediction of time. Whenever the dependent variable is scale and you want to predict the scale variable, that's when you use a linear regression model. Independent variables can be scale or it can be categorical. Independent variables can be scale or categorical. Now, we know that sometimes you may get confused. Why? Because you're thinking in terms of linear regression. Don't think in terms of linear regression. Think of the Boston housing data set and the example that we worked on. What did we try to predict? That should be, that's how your mind should go through. What did we try to predict?
the price.
Housing price. Was that a categorical variable? We had a scale variable. So that's the story. We were trying to predict a scale dependent variable, right? So is this an example of a supervised learning technique or unsupervised learning technique? Why? Very good. Very simple and straightforward. We have a dependent variable. The moment I have a dependent variable, it's an example of supervised learning technique. Linear regression, right? If you go back to your 8th standard mathematics or 10th standard mathematics, you would have learned y equals mx plus c. That is what we are using. Y is the dependent variable, x is the independent variable. There are 2 types of regression models. Which are these 2? Logistics, forget it. Within linear, let's just focus on
single and multiple.
exactly. Simple linear regression, SLR. That is your one type of model. Second type of model is MLR, multiple linear regression. The adjective multiple there in multiple linear regression refers to multiple independent variables, right? I can have 10 different independent variables. So in the Boston housing data set that we worked on, was that an example of simple linear regression or multiple linear? Multiple, because I had so many independent variables. I had many independent variables. Correct? So this is where and when I use a linear regression model. If you look at, yes, Charles River was there, right? It was 0 or 1, that was category. Right? Charles River, that is not really a scale variable either. In that nearby locality, Charles River is flowing, they're coded as 1. Yes, if there is nothing, you're coded as 0. That's a categorical. We have taken that. We can take it. See, usually what happens is that if it is already Charles River 1 and 0, if you have independent variables, take it as it is. If it is many times, you may have variables like gender, male and female. That we say it has to be dummy coded. You'll see an example of that in today's class.
Category, so you take not gender, especially if I have a category of models of cars. Then
I understood. So in one variable, you have 20 categories.
Yes.
Understood.
And
So I'll tell you. So his question is basically gender is fine. Male and female, 1 and 0 will code. But there may be, let's say, states in India. States, if you see, here we have around 29 states, if I'm right, correct? 29 states. So how will you work on this? So 29, N is 29 there. So N minus 1 dummies you have to create. 28 dummies you have to create. Which means if I am coming from Karnataka, there is one dummy variable called as state underscore Karnataka. So it will flag who are those people who are from Karnataka. I am from Karnataka 1. He is from Karnataka, let's say 1. You are not from Karnataka 0, 0, 0, 1. You're from Karnataka 1. So whoever is from Karnataka, it will flag as 1. That is one variable. Whoever is not from Karnataka, 0. Let us say second dummy variable will be Orissa. I am not from Orissa, so it will create 0. He is not from Orissa, 0. You are from Orissa, so 1. You are not from Orissa, 0. Right? Like this, if you have n categories in a variable, n minus 1, 1 less than that, how many ever, those many dummies you have to create and then take that as the independent set.
Is there an that's my second question. Like, is there an easy way you have to
because there is an easy function which we'll be talking about called as get dummies function in pandas, which will in one shot create these dummies.
Creating the dummy, if there are hundreds of categories, we can create 100 columns. Can we any other method used without creating that much of dummy?
We don't have any other method. Usually, if you read literature and such things, if a variable has more than 10 categories, any variable which has more than 10 categories, by and large, it is treated as a scale variable. If it has fewer than 10 categories, that's when literature theory says that you can basically go ahead and create dummies and such. If any variable has more than 10 groups or 10 categories, you treat it as though it's a scale variable.
In real life,
Really,
like any case scenario, use case study.
more than 10 groups.
So we can relate
State itself is one example. State itself is the best example.
So we have to add that as a scale variable.
Usually when we have state and such things, correct? What is people will be interested. Let us say for US market, you build a model. US market, or for a specific market, they ask us to build a model. Right? So what we do is basically in that case, we can just take a random sample of each of these things. Right? State is one factor. Right? You have the variable state. Somebody is from USA, whatever it is. You may have 29 states. What you can do is basically for US people itself, you can build a separate regression model. For Mexico people itself, you can build a separate regression model. But in that case, you will have to build 29 regression models, which is a bit of a problem. Right? So in those sort of cases, what the general thumb rule, the general rule of thumb, or the general way in which we operate is basically that we take one market, by and large US as the benchmark, and all other English speaking markets, English speaking markets we'll tend to group as one. English market is one, non-English market is another, like let's say Spanish culture and such things. And we try to build 2 or 3 different models. Not 29 models we can't build. So by and large, English speaking and democracies, their characteristics by and large are assumed to be same by and large. Non-English speaking market by and large are assumed to be true. So for non-English speaking, you can just club them as separate, and you can separately build a model.
States there are 29.
Yes.
They can also put it as 1 to 9 and then normalize them and can be different.
Usually, when we speak about normalization and such things, if it is strictly a scale variable, usually the question of normalization comes into picture. But for state and such things, what people do is either you create 29 dummies or try to further classify them as English markets and non-English speaking markets, something. Group them into 2 or 3 areas. Then you can say, sir, English speaking markets are behaving like this, non-English speaking markets are behaving like this.
When the things like variables, let's say we have put them down and by in the implementation of this, just make the area of the variable.
So I didn't understand it.
Explain. Yeah. If there are just 2 independent variables, now I have one general variable, then income is a 2 variables, and then I want to say the spending. That's a different variable. So the income and the spending, they are more or less similar things in terms of view. How the general will get into that section in the linear equation.
We see gender basically, because it's a categorical variable, you're saying this, right? So yeah, I think we have some examples.
I was just looking at what is the significance of these general variables with the
Other variables. See, at the end of the day, what happens is that you will get some coefficient. For gender, you will get some number.
Okay.
Correct? So let's say gender means only 2 categories, male and female. Let us say you're comparing males as the benchmark. One of the categories will be the benchmark or the baseline category. Then you will get the coefficient for, let's say, females, which means that, let's say the coefficient is 2, and you're trying to, I'm using your example of income. So if you're getting the coefficient of 2 there, it means that female income is twice as much as compared to that of males. In comparison to males, female income is twice. If you're getting a positive number, if you're getting a negative number, it means that female income is half, or it is 2 times lesser as compared to that of male. So one of the categories should be considered as the baseline, and the rest of the categories will be compared on this baseline category.
Even the variables that are not variables.
Yes.
That also will.
Yes, you'll get one question. So usually for categorical variables, what happens is that the entire idea of dummy coding and such things, any of these things, if you have 6 variables, so 6 categories, you will get the quotients for 5. The 6th category is considered as the baseline category. So when you are getting the quotient for these 5, you will be comparing the quotient for the first category with that of the 6th, second with that of the 6th. For example, in COVID, I'm just giving an example of COVID. Let's say the capital of India, Delhi, is considered as the benchmark. So for Karnataka, I'm getting a quotient of 2. It simply means that the incidence of COVID in Karnataka is twice as compared to that of Delhi. So here, when you have a categorical variable, you compare it with a baseline category. And then you say whether for that particular category which you're comparing, is it higher than the baseline category or is it lesser than the baseline category? But for a scale variable, it is a direct. If 1 unit increase, what is the corresponding impact? If my income increases, will my spending also increase? Or if my income decreases, will the spending decrease? So it is basically 1 unit increase, how will the other behave? But when you have a categorical variable, if you have 2 categories, one is considered as the baseline category, benchmark category, and you will get the quotient for 2 minus 1. One quotient you will get. It is actually about.
I mean, let's say, why we not given X? Yes.
There is no. Find a marker. One second. See, you have, this is my general equation, y equals mx plus c. Right? Now, let us say in our case, we are trying to estimate spending. We are trying to predict spending. Spending equals, the first variable is what? The first independent variables. The first independent variable, let's say, is income. Second independent variable is gender. Correct. So this is the first independent variable. So next to income, I will get some quotient, let's say 3 times income. So 3 multiplied by income. I'll put a plus sign. So here this is taken care of. The confusion seems to be for this here, because gender is split up as males and females. If you dummy code this and sort of run the regression model, you'll get one quotient. You'll get one quotient. Let us say I may get a quotient of -3. I may get a quotient of -3. So this -3, this is separated, right? -3 times gender, right? If you have coded 1 for males in the column, whoever is a male, if you have coded 1, for that 1, you are getting the quotient. If the males, all the males are coded as 1, for that particular category, you are getting the coefficient. So which means that this coefficient is relevant for the male gender. So which means that since we are talking about spending, men tend to spend 3 times lesser as compared to that of females. Yes, we code it as 1 and 0, right? 1 and 0. So the coefficient is produced for 1, the category 1, not for 0. Let us say, sir, you may say, sir, I am not interested in treating the females as the baseline category. Give me the coefficient for males. Then you have to do ulta. Code for whichever category you want the coefficient, code it as 1. The others you can code it as 0. That's it.
The way we will be coding this is income.
Yes.
Then I'll put it as name and then I put it as female. And this is how my understanding is. So this is person 1, person 2, person 3. So this is 10K, this is just some number, this is 200, this is 1. And here I'm putting that this is 100, 01. So I'm indicating the 2 females and 1 male. So I'm expecting that in my y final equation, the beta naught is the C plus beta 1 x plus beta 2 y x1 x2 and c. So in this case, I'm expecting y is equal to p naught some constant, and this may be the set value from the this one. So here b1 is this inc, b1 is a coefficient, so this is b1 we will get, x1 is inc plus b2 I'm expecting m plus b3 b1 is here, b1 this is b2 m here, yeah, plus b3 x3. So b3 into female. This is the I am just kind of expecting, and expect these all coefficients to be coming. So if I give a person like, for example, I want to estimate for the P4 question 1. So y is equal to all these things. So we'll be able to whether the P4 is a male or female based on that. If male is 1, female is 1, then this term will remain, this will go, and otherwise this term will remain and this will go.
This is one way of looking at it, right? So usually, right? This is one way of looking at it. In fact, if you put it as PD.dummies, if you do, it will create dummies like the way you're showing. Male and female. But if you actually think of it, we are getting into what is called as dummy variable trap. Dummy trap. Right? Because you don't need this additional column at all. Because anyway, if a person is one is male, the other category he is not 0, therefore he is marked as 1. So one of these 2 columns actually can be dropped.
That's why you're saying 59.
Exactly. Exactly. How many other categories you have? One less than that is always better.
Publishing C is different.
Yes. But they're not using it for regression or anything. They have just given the data set like that, but they're not using it for regression kinds of stuff. Usually the concept of dummies is that basically, if you have n categories, n minus 1 dummies should be created, not n dummies. Because otherwise you'll have, you'll get a coefficient for this, you'll get a coefficient for this. As he's saying, basically, you'll have too many variables. Correct. So what we do is basically, the ideal way is basically, if you have 2, treat one as the baseline category, obtain the coefficient for the other.
You'll be able to reduce only one n minus 1, only one variable.
N minus 1 categories. N minus 1. Correct.
This case, if you have another column, transit, that's how it will go.
Male, female, and let's say transgender. So if you have 3, it is 3 minus 1. Which of these 3 things which you do want to consider as baseline category? Let's say transgender category. So the male spending is twice as that of transgender category. That is the kind of interpretation you can make. or the female spending is twice that of the transgender category. Usually the concept of dummies is that you create n minus 1 categories. The latest quotes and such things, basically they don't have the brain. They'll give you, if you have 30 categories, he'll give you 30 dummy variants. If you have 2, as sir is written, basically you will get 2. But if you actually look at it, see, why do I need an additional column here? If I have this, this becomes redundant. If I have this, so if I have this, this becomes redundant.
Have additional, just putting place around it. For me, it is difficult.
If you have 3, is it?
So let us say male is 1, female is also 1. Then what you need to do? If you don't put that column, what is the?
So you will have 3 minus 1 categories there.
How will
How will we?
coding for that?
Coding for 3 categories. So basically,
You can just add DG there.
so actually this works when you have 3 categories.
But in case of male is 1.
Correct.
What is transgender? That is also 0.
There's also 0. Yes. He's not a transgender. A person is not a transgender. So for example, let us say, now shall I write this? Let us say there's a variable transgender with 3 categories, right? Let us say we have ID. First person, let's say this is the first person, this is second, this is 3, this is 4, and this is 5. Correct? Original data is in such a way that this is male, this is female, female, transgender, transgender. 6th is, let's say, male, something like this you have. So you're saying basically there are 3 groups, right? Now, how should this be ideally coded? Right? How many groups are there? This is the first group. This is the second unique category, and transgender, this is the third unique category. Correct? So if you have to code this is ID variable, and then you can create a variable gender. If it is male, I'm just using the subscript male, and let us say one more column, which is called as, let's say, females. The first person, correct? He's a male, so I'll mark it as 1. This will be 0. He's also not a transgender, right? Second person, she's a female, so this will be 1. This will be 0. Third person, this is a female, so this will be 1, and this will be 0. Fourth person, neither male nor female, so it will be 0 and 0. Okay. Fifth person, transgender, 0 and 0. Sixth person, male, 1, and this is right. So 0, 0, wherever you have, that is the baseline category. Yeah. Yeah. So it is upon us as to which category do you want to make as the baseline category. Right. Now here in this example, transgender is the base category, baseline category. I remember in the good old days when I used to use SAS. SAS, how it takes is basically SAS dummy coding and such things. It goes by alphabetical order. A, B, C, D, E, F. F first comes first. So it will not be created as a baseline category. A, B, C, D, E, F, G, H, I, J, K, L, M. So M will also not be created as a baseline category. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T. So T is in the last, if you look at the ascending order. So SAS and such things would consider whatever is there in that particular order, last whatever comes, that is the baseline category by default. Python, basically we have something called as get dummies. So it will create, if there are 5 categories, 5 dummies it will create. It will give you the coefficient as sir is saying.
And we have to drop anyone.
Anyone, if you want, ideally speaking, it is best to drop. Okay, so now I'll just finish this. Okay, now I'll just explain this part, correct? how do you obtain? So now let us say, sir, SAS does not have the brain, correct? How can a tool decide with what can be the baseline category? They have given based on the alphabetical order it arranges. Now, when we used to work, I remember, how can one particular category be called as the baseline category by the tool? Let us say, I want to treat female category as the baseline category, but SAS does not take it. So you know what we used to do? What we used to do is basically in the data set, correct? Let us say if you want females as the baseline category, in the raw data set itself, we would use Z_F. The rest of the things, let it be like MF. This is T. So T is, I want the quotient for this, so I'll keep it as it is. This is T, but for males, yeah, so for this also should be Z_F. Males can be as it is. So now what SAS is reading A, B, C, D, E, F, G, H, I, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. This is the last letter. So this will be treated as the baseline category. So whichever you want, just put a Z_. That will be going as the baseline category in SAS. Here, the latest technologies, if you look at your Python and such things, 5 variables means 5 dummies, it will give the quotient for everything. But ideally, it should not be like that. It should always be 5 minus 1. How many ever groups you have? Minus 1. Because at the end of the day, fewer variables are better. One category should always be treated as a baseline category.
That's what. Therefore, how we can.
Which one?
Because it will take randomly as anything as
You should ask yourself a simple question. Do you want the quotient for males or females? If you say both, it's very difficult. If you say both, it's very, very difficult. On the other hand, both may not be also desirable. If I have one, I can compare it with the others. So for categorical variables, comparison is always good. So if I want the quotient for males, I will treat females as the baseline category. If I want the quotient for females, I'll treat males as the baseline category.
So that I understand.
Yeah, but how do you decide?
Yeah, how do I decide and how do
I decide? So I'll just tell you. See, so if you want the logical explanation as to how do I decide? How do I decide? In the entire data set of 100 records, let's say we are building a response model. What is the average response rate you take? Mean response rate. Out of 100 people, let us say 20 people have responded to your campaign. So 0.2, this is the baseline response rate, mean response rate. So first you pull out the mean response rate, which is around 0.2. Correct? This is the overall response rate regardless of gender. Now what you do is basically you calculate the response rate only for females separately. This is part of your EDA, not your model. Correct? Now let us say you will get 0.3. Or let us say usually you may get something like 1. Let us say you get 1.9. Now you calculate the response rate for males. Response rate for females means what? Out of the females, in the denominator you'll have the count of females. Out of these many people, how many have responded? The numerator. So this is 1 point. Correct. So what is the conventional rule of thumb is whichever is closer to the global response rate, you take that as the baseline. So 1.9, the average female, her response rate is very close. 1.9 is very close to 0.2. Then you consider female category as the baseline response rate. This is far. Their behavior is different. Therefore, I would rather have the model produce the coefficient for this, not this. So individually, this is the essence of EDA. Exploratory data analysis and all when we do, why do we do this exploratory data analysis? So that all these decisions can be made. So tomorrow if the client comes back to me and asks, why have we chosen particular category as a response rate? Because their response is very close to 1.95, which is as good as this. It does not tell me anything. It is the average. I am interested in those people who give me a response rate which is tremendously higher than the average or something which is lesser than the average. So this is the science period. So that is why we would create an Excel sheet wherein we would highlight which are the things which we, as per our understanding, we think in UK basically. Since I have worked for UK market, we used to have different localities there, different what is it called, counties, I think. We had different counties. So let's say Norwich is considered as a response rate. Why? Because their response rate is very close to the average response rate. It is as good as zero itself. That is the benchmark. Anybody who's giving a higher response rate than the baseline, or anybody who's giving extremely low, their coefficient is what I'm trying to pick up. That would be our argument, and that was nobody would question this. Yes. If you have two categorical variables.
Gender is one. And I have
Marital status.
language.
Language, yes.
What is language again? Speak fine. Then the general term. So also even
Yes.
gender
Separately for language, separately.
and the
N-1 here, N-1.
Yes.
Okay, I'll write this. Okay. So for linear regression is clear. Right, we spoke about, right, we did a heat map to understand. So in the heat map, what are some of the insights that you can pick up?
Relationship between independent and dependent variable. So the independent.
Yes. Right. If you recall the heat map, see, these are the things which you can say the same thing in an interview. Right? Which all variables are related with dependent variable? Which all variables are related amongst themselves? Those variables which have a high relationship with the dependent variable is a good sign. Let's say a variable has weak or negligible relationship, and if you feel that a variable is not at all influencing at this stage itself, you can filter out variables. If you have too many, the problem of too many, if you have too many variables, discard a few variables which have low relationship. Correct? I can take only those variables which have a high relationship with the dependent variable. So your heat map and such things can act as a variable filtering mechanism. Correct? So I can understand which are, so these itself can be a few insights, correct? And then what did we do? If a lot of variables, independent variables are related to each other, basically your model will be unstable. The later model that you build will be extremely unstable. As far as possible, independent variables should be independent. They should be uncorrelated, right? Correlation with a dependent variable is a good sign. Correlation amongst the independent variables is a bad sign. Very good. That's the technical word is called as multi-collinearity problem, which is the language of a statistician. Usually machine learning guys these days, they say it leads to the problem of overfitting. Sorry, sir, you have. People say both, sir. Both are ideally speaking, most textbooks say multi-collinearity, but in spoken English, people say there is a problem of collinearity.
It's close to overfitting.
It's close to overfitting.
When it's underfitting, like when testing is more, training more, and training is less.
Yes, less. Then you can say it's underfitting. Okay, so far we are clear, right? So let's say with this, basically, we can use this as a variable selection, right? Out of 20, we can just maybe freeze and to with 15, 20, take out of 20, we can freeze, we can drill down to 10 or 12 variables, feed them into the model. Then we can generate the p-value, see which of them are significant, see which of them are insignificant, right? That is purely from the insights perspective, right? We did both styles of modeling. First is basically split the data into training and testing. We got the coefficients that though the coefficients that we obtained, we implemented on the test data, right? So, right, we implemented on the test data, right? What are the model diagnostics that we looked at? R square. What is this R square? How good or how bad your model is, but you should always use a data scientist language. What is this R square? There is a phrase, there's an expression that we use. Exactly. So that is what you have to say in an interview or in a Viva, right? People usually say, well, sir, Viva, I did very well. No, you're not using a data scientist language. We looked at the coefficient of determination, which is R square. R square was this. R square lies between 0 and 1. Close to 1, it means that the model fits the data well. Close to 0, the model does not fit the data well. Anything which is greater than 0.7, it means that the model is good. Above 0.90, it is very good. Right? You should use the data scientist language, not this, that, model diagnostic. R square is fine, but use coefficient of determination. Right? R square. Correct? We interpreted that. Alternatively, we could also look at MSE, mean square error, and mean absolute error as well. You can look at any of these three things, but R square for all practical purposes is good enough. R square for all practical purposes would be good enough. R square is 0 and 1. R square, because you're squaring it, right? R square is between 0 and 1, right? Yeah, we can. We actually quote it from percentages. With decimals and all, convert it into percentage, very simple. At least 70%, yeah. Right? Which means if you get a R square of 0.72, what does this mean? You should be in a position to interpret it. If you get the R square of 0.72, it means 72% of the variation in the dependent variable is explained by the set of independent variables that I have. 72% of the variation in my dependent variable is explained by the set of independent variables that I have. It automatically means that, right? Reading between the lines, they say, right? 72% is explained, 28% is unexplained. It is unexplained because if you go back to that pricing model, housing price, there may be so many factors which may influence the price of the house, not just the factors that we have taken. What we have taken, those are all numeric variables, right? Because data could be collected for it. So those are all factors which are called as quantifiable factors. There are so many things which are non-quantifiable factors, which cannot be taken into account. So many things, people's perception, locality, MLA, MP, I don't know. There may be so many things which influences the housing price. Perhaps you can't take everything into account. Those factors also drive housing price, but we do not have it in our data set. They account for 28% of the variation, which is not accounted for. So that is what we say, 28%, that should be lesser, right? Percentage of variation that we are accounting for should be higher. Higher the better. At least 0.70 and above is acceptable. Theory says above 50% at least should be is a good thing. Exactly. Yes, yes.
Other 30% I would
Yes, there are external factors. Correct. That's the right line. So there are external factors will also influence. Those external factors can be one or several. We can't hunt behind it.
If you can give me all these values for each one of these parameters.
Yes, yes, yes. Yes. Okay, so that's about your linear regression. Yes, it can be anyway. What happened? Shashikala, she raised. Madam, you have some question, madam? Hello? If I have categorical variable with more than 20 values, then do we create n minus 1 dummy variables considering n as 20? Is it right? How far it is feasible to choose this mechanism for large values? You are absolutely right. Right, n minus 1, that is the thing. But these days people just, they don't go to this extent. Large or small, this is the one thing. Any number of categories that you have, n minus 1 groups is what we make. 99. Yes, so I hope you are able to listen to me, madam. Yes, so your second part of the question, is it right? Yes. How far it is feasible to choose this mechanism for large values? So if you're saying when n is basically very, very high, n is basically like, let's say 20 or let's say 40, 50 or something, right? So usually when we get n is equal to 40, 50 and such things, there's a thumb rule. We discussed this point that when the number of categories is greater than 10, you might find a PDF even now. There's a research paper which is written as well, which I read sometime back, long time back, that when n is usually greater than 10, you can treat it not as a categorical variable, you can treat it just as a scale variable itself. You can just treat it as a scale variable because there are so many levels. We don't treat it as a categorical variable. Categorical 2 groups, 3 groups, 4 groups, still fine. But if you have 99 categories, 100 categories at all, it is best to treat it just like you treat a scale variable. Right? No, just treat it like that. It's one coefficient you will get at the end of it. For state, you will get one coefficient. Okay. So far we are clear? Yeah, please. You don't have to ask me, okay? You can just please feel free. No, that's okay. Okay, what I will do is, so now that logistic regression, sorry.
I drop some of the things. Drop some of the things, yeah.
But you know, just the answer for that is this. Let's go back to the example. When we did the stacks model of we ran the regression, we got around 17%. And two of which variables that we dropped and we reran after the model. Because by definition, drop insignificant. You're saying drop also should have a convincing reason. So why are you dropping? So the business feels that it is not mathematically easy. So that's why when we drop two variables, I think we dropped the index and another variable. So that ask for value by as far as possible drop significant variable if you drop to ask for insignificant. That's why it's called insignificant. It is not adding much value. P value. The final authority is always for P. If P is less than 0.05, so any variable with a P value bigger than 0.05, you can afford to drop. It is not at all contributing. Yes,
We have to go to one situation and by certain thing, something is variable second question. What is the variance?
Yes, this principal component analysis is one such technique which helps you drop variance. And this analysis is a variable dropping technique nobody uses. These days we have three techniques. One is called as Laszlo, LASSO. Second one is what is called as elastic net. And the third one is what one called as the regularization technique. Okay, handled by Mr. Ratnakar. Right? Regularization technique, L1 regularizer, L2 regularizer. Very simple. Right? It will basically tell you when you have all this typical problem in your peers, how you take that. Ridge regression. Ridge regression is one more technique which when the data has a lot of linearity and I don't want to can handle. These are three techniques in the industry as well. PCM such things 10 years back people used to. Sorry. There's a lot of flavors of having some. Honestly, I think that having given you say that he very nothing the heat now. You're saying that there are variables and there are moderate correlation with it. Or moderate. I mean, when I say drop it, I mean, if I have 50 variables, my focus would be on drop. If I have 5 variables, I'm not so keen on dropping because I already have just have 5 variables in my dropping will reduce the size. So the second case, if I have fewer variables, I will be keen on concentrating those variables which have a model. The first case, when I have the problem of plenty, when I have got 25, 30 variables, I can approach it. So do you have the problem of plenty or do you have a problem? Yes. All data you have to fight for everything. Fight for everything. Because that variable obsolescence. Exactly what very rarely you find that moderate. And there's always a business angle to each of these. Are both of these variables fully important? Maybe they are not equally important. But if somebody says that keep both, because business equals to what is the mathematical consideration? Mathematical considerations can always be overlooked based on the business. Business means both of these are important because at the end of the day, I can't predict sales without price and resale. Price is talking about money, resale is also talking about. Both these variables are important and go ahead and go with it. Business will trump mathematics.
One and we in a bunch of data.
Yes, yes.
Other side, we don't want to go much of data. They have a balance between data and business.
Okay. So day 4, what we'll be talking about is a technique which is called as logistic regression model. Right? Specifically, there are two types of logistic regression model. Binary logistic regression model and what is called as multinomial logistic regression model. Binary logistic regression model and multinomial logistic regression model. In the case of linear regression model, what did I say? I said that the dependent variable there is a scale variable. But $80 to 90% of the real-time problems, real-world problems, are not based on scale-dependent variable. When you are predicting a scale-dependent variable, it is also called as a prediction problem. If you are trying to predict price, sales, those are all regression-based problems, or it's also popularly referred to as prediction problems. On the other hand, there are many situations wherein your dependent variable may not be scale, it may be categorical in nature. When the dependent variable is categorical in nature, don't use a linear regression model. Don't use a linear regression model. What is the alternative? The alternative is we use a technique which is called as logistic regression model. Logistic regression model. Yes. Classification problem. Yeah. Because the dependent variable is classification problem. Correct. Classification is there. Or you can say basically the dependent variable is scale. In this case, there are a lot of regression based problems. Non-regression based problems. And 80 problems, 80% of the problems that you encounter in the industry setup, the real-time scenario will always be, will usually, not always, usually be a classification-based problem. So there are a lot of techniques which speak about classification. How do you handle classification-based problems? In fact, your entire career many times will be based on just running classification models. If you get into it, your entire career you may spend running just classification. You don't need other regression based, because the kind of data and the business problem may always be classification based. I'll give you. I'll give you. Right?
Prediction based problem also.
No, see,
it's diabetic or not.
You're predicting a class there, but usually, specifically, we refer to it as classification-based problem.
It is not referred as prediction.
It is not referred to as prediction. You're not calling it as prediction.
Once a prediction, it will be
Usually a regression-based problem. It's called as regression-based problem. Right? So here we'll be discussing some of the classification problems in the industry. Right? One such technique that is basically logistic regression model. Thirdly, the model diagnostics that come into picture. Fourthly, one use case or two use cases. And lastly, the disadvantage with the existing technique that is logistic regression model, which I'll be talking about. Once I end today, whenever Mr. Ratnakar Pandey will come, he will basically address on other techniques which can be used for classification. I will be focusing only on one of the techniques, which is your logistic regression. Typically, here, let me just give you an example. Let us say I'm running a bank. I'm a bank manager, right? And there are 1,000 people who have applied for a loan. It's an education loan you have to give me, correct? Question before me is, can I give a loan to every Tom, Dick and Harry? I can't give a loan to 1,000 people. Why not?
like how many funds you have, and if there are credit.
Your credit risk or credit worthiness comes into picture. Are you a high risk customer or a low risk customer? If you're a high risk customer, it's a problem to me. You take the loan, after 3 months you default, then I am at a loss. I have to run after you. You may not be able to repay the loan. Right? It's a big headache. Correct? I don't want such customers. Correct? Who can't repay the loan. I am more comfortable giving giving loan to a person who has a decent credit rating score. So I need some kind of a score which tells me even before, right? There is no point being wiser after something has happened, correct? After you have stolen me, after you have defaulted, then I come to know you're a defaulter. There's no point, right? At least I need some kind of a model which tells me out of these 1,000 people, these 70 people are good people, they can be trusted, right? These 30 people looks like they're shady, they're dubious, so don't give them a loan. I need some kind of a mechanism, right? That mechanism is a binary logistic regression model. Right? This is a mathematical framework which basically tells you who has what kind of a propensity to default on a loan payment and who has what kind of a propensity to pay the loan sincerely. Low risk customers, the moment I come to know that XYZ individuals are low risk, I'm comfortable giving the loan. They're low risk, fine. High risk, there's one individual who's 90% risk, was no, not comfortable. Please forgive. Correct. So my risk, overall risk and such things will be less. The background for this, if you ask me, till 2000, right, in India and US, our model of thinking itself is very different. In India, basically, if you see here, home loan and all, if you ask, basically, it is quite expensive, right? 7.58, I think minimum you will have, right? In US for a long time, home loans and such things were very cheap. It was less than 1%. Sometime back. The entire idea is basically the economics there. They followed a different kind of economics, saying that if you reduce the interest rate, I will be encouraging people to purchase. If I make the interest rate less, very less, then more and more people will basically, apply for a home loan, credit card. Then basically, as more and more homes will be getting built, more and more, which means basically more and more cement producing factories and all these industries and such things will come into picture. Jobs will be created like this. So this is their model of thinking. So encourage consumption. If you encourage consumption, production will automatically be given a fillip. So they did this and it worked for some time. But in 2007, what happened is that when they made home loans and such things very cheap, all these MBA graduates, pass outs, they started buying loans. Right? A guy has recently passed out, right? 20, 21 years old. He does not have sufficient maturity level. He does not face the heat of life. Every Tom, Dick and Harry basically, pass out of college, fall in love. Next thing is basically, settle. Anyway, country is giving a loan for a very cheap amount. Why will I not use it? So everybody started, every Tom, Dick and Harry had a home. But 6 months down the line, 3 months down the line, 4 months, 5 months down the line, when many of these people started getting laid off, they did not have anything to pay back the loan. They did not have much to pay back the loan. And when they returned also, they were more than comfortable. No, we are not able to pay back, you take the home. And most of these were, all AC related, they had AC. Maintaining an AC related home for the bank also became very difficult. So many banks in US started suffering and they led to closure. This is where your Lehman Brothers and other many famous banks, they started shutting shop. So what happens in United States of America will get translated into Europe, and what happens in US and Europe will get translated in India. But we were not encouraging, mindless giving away of loans and such things. Now after 2007, if you see here, there's a lot of emphasis on understanding credit worthiness of a customer. You can't give a loan and such things indiscriminately. You need to be more careful about giving a loan. So this is where a lot of your mathematical models, statistical models, AI models come into picture, wherein even before I give a loan, I want to size you up properly, whether you can or do you have the capacity. It does not mean that you'll never go wrong. My model may say that you're 80% good, but tomorrow, because of some accident or fate, something happens, you turn out to be bad. But that is a lot better than indiscriminately giving loans to every Tom, Dick, and Harry. Correct. So this is where, when it comes to credit risk analysis, this is used. Banking, this is one of the favorite problems. Secondly, who is the fraud and who is not a fraud? Fraud modeling and such things. You look at the thing. There, the problem was to identify whether a person is good credit risk or bad credit risk. The outcome variable is binary, correct? Sometimes it's just, oh, oh, is it? Oh, that is this. Oh, project. Sorry. This switched off completely. Yeah?
There only.
Turned green. Okay. So one is bank. Okay. Second, please. No problem. Please. Bank. Correct. Now let us move to fraud modeling website. Who's a fraud and who's not a fraud? Correct. Third one is, if you look at telecom companies and such things, mainly telecom companies, what happens with telecom companies is again the same thing, that some people churn. Some people churn every month, they churn, they leave and migrate from, let's say, Vodafone to Airtel and vice versa for some other problem. So if you have 100 customers, I want to know who has a propensity to churn, who does not have a propensity to churn, who will churn, who will not churn. Correct? So what is the problem that I'm modeling? Again, a binary problem. It's a classification problem. So whether it is credit risk analysis or churn models, right? These are popularly called as churn models. Or many times in when you are talking about campaign analytics, direct marketing campaign and such things, or even for that matter, digital marketing campaign, my fundamental goal there would be to understand who will respond to a mailing campaign, who will not respond to a mailing campaign. I repeat, who will respond to my mailing campaign, who will not respond to my mailing campaign, yes or no. Correct? Many times, a lot of people ask for access request in your IT companies, correct? I want access, I want to access this, that, blah, 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 right? Sometimes permissions are denied, sometimes they are basically given. We were working on a similar problem for Sony, wherein basically they had data. Based on the data, they want to predict whether a person should be granted access or not. Again, so this is again a problem of classification itself. Correct? Mails, whether a mail is a spam mail or a ham mail. Correct? Whether a person will respond to a drug or not respond to a drug. All these are classic classification based problems, which your linear regression model cannot handle. Correct? So these are all some of the problems which cannot be handled by linear regression, and therefore we move on to a technique which is called as logistic regression model. We are mainly looking at a problem which is called as binary logistic regression with two outcomes. Yes, no, fraud, not a fraud, respondent, not a respondent, spam, not a spam, right? These sort of problems, right? In HR, people who will attrite or leave the company or people who will stick with me, those sort of things. Correct? So your logistic regression model comes into picture. Now, what are the key features of a logistic regression model? Now, there are 3 or 4 important points here that we need to highlight. It is again a supervised learning technique. It's a machine learning technique, which is what is called as a supervised machine learning technique, because here again, I have a dependent variable. I have a dependent variable. Shall we take a small break and come back? Right, we'll have some coffee and come back. Yes.
Yeah. It is coming.
Yeah, come.
You want to check out the books? Huh? You want to check out the books?
All books. Thank you.
No,
रोटी कराई है मुझे जो मेट्रो वन बड़ा छोटा रोड ना
अब पता ही नहीं चलता कि बस लेन में चलाना है कि नहीं चलाना है।
हाँ लेकिन चलाने का टाइम हाँ मतलब तो बता दो हर जगह लिखा हुआ है मॉनिटर नहीं
कैमरे कहाँ लगे हुए करते हो?
Okay. Ma'am, I hope I'm audible now. Is it any better? Ashutosh, day 3 second session video needs to be uploaded. Can you please do it? Day 3 second session video needs to be uploaded. Can you please speak up, Ashutosh? Hello? Maybe I just call him up in lunch. Just remind me once.
Yeah, because
it's not uploaded. Huh?
no, sir. Is it like taking longer time to upload this kind of videos in the LMS?
I don't think it should ideally take so much time.
It should take like hardly
Less than half a day. It should.
Yeah.
Okay, we'll come back to this. So we are talking about logistic regression, right? So we said that it is a supervised learning technique, right? Firstly, we are predicting a categorical or a binary dependent variable, wherein the outcome variable is yes, no. Default, non-defaulter, fraud, non-fraud, that kind of a situation. It is very similar to linear regression. Just that linear regression cannot handle such situations. So I'll tell you, there is some modification that we have to do with the linear regression to arrive at the mathematical foundations of logistic regression model. I'll just discuss this, right? Now here, in the case of a linear regression model, what did we do? It's almost like a 45-degree line that we drew, y equals mx plus c, which is what was used to separate, which is what was used to predict the outcome variable. Here, we are going to use what is called as a S-shaped curve. We are going to use a S-shaped curve, which is also popularly referred to as a sigmoid function, to classify people as respondents versus non-respondents. Correct? I'll just show you this. Okay, so this is at a high level what we are doing, correct? So in linear regression, sorry, in logistic regression model, what we are doing is basically you take the independent variables, you identify the importance of each of these variables, call this as theta 1, theta 2, theta 3, take the sum product of it, process it, and then you can identify which class does a record belong to, happy or sad. Here is I'm just taking a very oversimplified example. I've just pulled out this image from the net. But for more complex real-time problems, you can just classify it as fraud versus non-fraud, which is what I'm saying. Okay, so how does the sigmoid curve look like? So this is how a sigmoid curve will look like, which is the foundation of your logistic regression model. Do you notice anything here? Do you notice anything significant, anything important here? Yes, exactly. So here you have the x-axis. X-axis is any independent variable. Y, if you see here, I'm limiting it between 0 and 1. So in the linear regression, when you're talking about the housing price prediction and such things, price can be from 0 to infinity. It can be any value, right? But here, if I get any value, if I get, let's say 50,000, how do I interpret it? Right? If I just multiply, may get any big value. I can't interpret it at all. So what we are going to do is we are going to take that and pass it into what is called as a sigmoid function. And the beauty of this sigmoid function is that no matter what you take and pass inside this, the output will always lie between 0 and 1. You'll not get a value above 1. You'll not get a value less than 0. Why is this so beneficial? The moment I take that value 50,000 or 5,000, 60,000, 60, 80, any number, and I get a probability score, if this value is bigger than 0.5, I can say that, okay, this gentleman, he has a higher propensity to be a defaulter. Let us say, I'm just giving an example. Let us say when I estimate, I push his age, income, tenure, duration of work, everything, and I get the value as 0.8. So there's an 80% chance, 0.8, it is greater than 0.5. There's a greater chance that he's going to be closer to 1. So I will say that this person is likely to be a defaulter. Let us say some other individual, when I look at all these demographic details and such things, I may get a value of 0.3. It is less than this halfway threshold. And therefore, I'll say that this guy is going to be a non-churner. So 50% is the benchmark. It is under your control. You can choose a higher benchmark or a lower benchmark, but I've not seen anybody play with this because 50% is a reasonable benchmark. So above 50%, the probability of him being closer to 1 is higher. Below 50%, the chances of him being closer to 0 is higher. So this is a reasonable approximation which tells me whether a person will churn or not churn, whether he'll stay or leave the company. So this is the mathematics behind your logistic regression model.
We never say there is an indeterminate state. 0.49. No,
Borderline cases.
we put it in zero case, but
Yeah, borderline cases will all you can always have borderline cases when a person is uh, very dicey. I do not very sure whether I should put him in the 1 category or the 0 category. Correct. Let us say I'm a startup company. I'm a startup. I've newly started a company. There, my goal is I'm hungry for customers. I want as many customers as possible because I don't have customers. There, possibly I can be slightly more lenient with a person who's got a probability score of 50%.
the problem there, 0.4, the score,
Yeah.
scores, we still say yes, he is eligible.
Is eligible, right? Because I'm hungry for customers.
Yeah.
Relax that condition slightly. Let's say I'm already a well-established company and 50 years of experience I have. There, I don't want to hurt my reputation. I want to be very strict with bad credit risk and such things. So if you are a borderline case, I'll not entertain you. Depends upon the situation. Business always, business considerations always, trump over your mathematical considerations. So mathematical form, it is just this, right? It looks slightly scary, but it's a very beautiful, very beautiful, and it makes a lot of sense. When I was in college, I used to find this very hard. What is this? What are they writing? I never used to understand. But now that you think of it, this is a function, right? This is a sigmoid function, 1 plus e power minus x. Correct? This is nothing but, you can also write this as, what is your regression equation? Linear regression. Mx plus c, that's a, right? Can I change the notation to beta naught plus beta 1x?
Yeah.
The notation, correct? So this beta naught plus beta 1x I have, correct? What is the sum product? Age of a person may be 30, the coefficient is 2. 30 into 2 is 60. This may be some 10. This is 70. It is not interpretable. In here, so this is the right hand side of your linear regression, right? This is the right hand side of my linear regression equation. Correct. Now right hand, please.
Just an form.
Okay. When you just take the sum product and multiply, you may get a value of 70. But here, let's say my product, my goal is to predict whether a person will default or not. How will I interpret 70? It is not possible for me to interpret. So what I'm doing is basically the foundation will still be the same. The foundation will still be the same. I'm doing a bit of mathematical jugglery here so that I can put some I can bring it into a more interpretable fashion. So what is the right hand side here? Let us say some 70. It can be 770,000 minus 70. Don't worry about it. It's a big number. It's a big number, which I'm not able to interpret. So I want it to hammer. I want to bring this down within that scale of 0 and 1. Above 0.5, high propensity to respond. Below 0.5, low propensity to respond. Now, how do I do this? Correct? Now, can anybody open Excel? Just open up Excel.
Yes.
Right? So this is the right hand side of my linear regression equation. Correct? What I'm going to do is basically, in the first step, I will attach a negative number to this equation. Correct? My right hand side, when I say this itself, this is my beta naught plus beta 1x. It is any number. Correct? I will just attach a negative number to this, which means if you have 70, it will become minus 70. If you put minus 70, it will become plus 70, opposite side. Doable. Correct? Once I attach a negative number, the second step that I will be doing is passing this through a function which is called as exponential function. In Excel, please type equals exponential of 70. How much will you get?
0.5 plus 30.
2.5 into e power minus 30.
Plus 30.
2.5 into 10 power minus 30. Can I say this? It is something like this, correct? Now, in the third step, what I will do is I will add 1 to this exponential of 70. How much will I get? 1 plus whatever you have got in Excel. Yeah, but can I say that, I mean, just for the sake of understanding, it is 2.5 into 10 to the power of minus 30, correct?
Plus 30.
Plus 30, okay. So 2.5 into 10. So this itself may be 25 million or something. 25 million plus 1 is, let's say, 26 million. I'm just, right? It can be any number. Don't worry about the number, right? So this I'm saying is around 26 million, whatever. Are you clear with this? Now, when I do a division, this entire thing, I'm just taking the reciprocal of this exponential of minus 70. Right? 1 divided by 26 million. It's a big number. Don't you think I will get a number which is like 0.001? Some number. It's a very tiny number. 1 divided by, as the denominator becomes bigger and bigger, the overall quantity will become smaller and smaller. So just look at this. In 3 or 4 steps, what we have done is the number 70 has come down to 0.0001. Something like that. 0.001 or point, right? It will be a number between 0 and 1. Right? If it is a number between 0 and 1, now I can start my game saying that I can specify a simple rule. If this number is above 0.05, greater chance of a person defaulting, less than 0.05, lesser chance of defaulting. So don't you think that when you are doing this, is this not your sigmoid function? This is what we are doing here. 1 divided by 1 plus exponential of negative value of your right hand side of the linear regression equation. 1 divided by 1 plus. This is the mathematical motivation behind your okay, let me just make a move on. So linear regression and logistic regression, what is the difference? This is the fundamental difference. Here we have a 45-degree line, right? Here, though it is showing y equals to 1, there is no upper cap there. It can take any value. But here there's a cap saying that, I want to limit, I want to clip its wings and say that this curve should be between 0 and 1. Predicted value lies between 0 and 1. This is the fundamental difference between linear regression and logistic regression. Straight line here, sigmoid curve here, right? Y equals mx plus c here. Here it is right hand side of the equation, put a negative side, pass it through the exponential function, add 1, take the reciprocal, job done. That's what we are doing. So right hand side of the linear regression itself, I'm just doing some mathematical jugglery to arrive at that value between 0 and 1. This is a good question, both from the point of view of your examination as well as interview. What is the difference between your linear regression and logistic regression? Usually, this is a standard question that is asked. See, here it is, we have already discussed predictor dependent output variable, which is scale. Here it is used to classify. The moment you hear words like classification based problems and such things, logistic should come to your mind. Here, the underlying engine is called as OLS, ordinary least squares. Here, the underlying engine is not OLS. We use a technique called as MLE, maximum likelihood estimation, to arrive at the rate coefficients. For each variable, independent variable, I need to measure the impact. How do I come to that conclusion? OLS does not help me. So there is an engine which is called as MLE, maximum likelihood estimation method. What is this MLE? Just simple one line answer. It's a method of parameter estimation. Yes.
So only for both of them, one engine is there at the background.
No, here it is OLS. Here the formula, everything changes.
For linear regression, we have OLS. So that is the only method, or there are many more methods?
There could be 101.
Okay.
There is
We are
something.
using OLS.
Yes, yes. Here it is OLS. Here it is MLE. Sometimes people can also use other methods also.
I was reading some. So there's some different methods.
Yes, Bayesian linear regression may not necessarily use OLS method. They may use their own method. 101 methods are there, right? Fundamental.
What is OEL?
Ordinary least squares. Right? So here the best line is a straight line. You just do 145-degree line, job done. Correct? Here the best line is given by a curve. You've seen that beautiful sigmoid shaped curve, S-shaped curve, which is the motivation behind your logistic regression model, right? The output is a predicted integer value. Integer means it can, in any situation, it can be from minus infinity to plus infinity. Here, the output is a binary value between 0 and 1. You've just now seen here, I will always get a value between 0 and 1. So that is very easy. Above 50%, greater chance of him being a defaulter. Less than 50% was lower chance of him being a defaulter. This is used in business domain, forecasting stocks and such things, linear regression. Here, it is used for image processing. Even you want to do image classification as well. I missed out that saying that. Let us say, based on a set of images, you want to find out whether there's a tendency for an image coming from the lungs of a patient to be tumorous or not. Is it likely to be tumorous or not? Use a logistic regression model. Okay, it has a lot of applications, 80 to 90% of the problems, correct? Even in text mining and such things, somebody has put a comment, right? Customer reviews and such things. You have ordered something from Swiggy or Zomato, whatever it is, you're unhappy with the service. Let's say from pizza you've ordered, you're not really happy with the service, they're charging too much, some problem you've had, customer review you have given. Now, I want to basically process it and say whether it is a positive sentiment or a negative sentiment. So you're predicting whether the sentiment is positive or negative. So for text classification and such things also, this is very useful. Image classification is useful, and all the list of problems which we discussed are all anyways useful. So you're familiar with this, right? Straight from linear regression, split the data, push it into a model, get the model output, score to the test data, then you'll get model R square. I've made a mistake here. It can't be R square. R square is not a model diagnostic metric. This is not the right metric, right? My apologies here. It is not R square. We have to look at other metrics here. So don't think of R square in the case of logistic regression model. So what are the model diagnostics here? So when we are talking about linear regression, we spoke about R square, mean absolute error, mean square error and such things. Here, when we are talking about logistic regression, when it comes to model diagnostics, we look at F1 score, precision, recall, sensitivity, PR curve, ROC curve. Not necessary that you have to look at all of these things. At least some of these things, 2 or 3 metrics should be very, very helpful. And I'll tell you which one has what kind of impact.
Precision is recall, right?
Which one, yeah?
Precision.
In a way, they're like mirror images. I'll tell you what is precision, right? Just know that these concepts are there. I'll tell you what is what. R square.
Yeah, R square.
Mean absolute error. Yes.
Test data is impacting our model.
It is not actually impacting your model. It is used to tell the quality of the model. Test data. It is the data which is used to test or assess or evaluate the quality of the model.
Can you just turn the slide to the
When we build a model, we score it on the test data, a fresh data set. We compare the actual versus the predicted. In the test, we have the actual. Let's say housing price only. Let's go back to housing price. For some localities, 30% of the cases we took it separately. We call it as test. For one locality, we have the housing price. As let us say 25,000 rupees. I'm just giving an example. Oh, 25,000. That is the actual data. You have built a model on the training data set. You'll have to apply it on the test data set and predict it. So you'll get the predicted housing price. The predicted housing price may be 30,000. So actual housing price in the test data is 25,000. Predicted is 30,000. So your model is actually estimating it higher. 25 minus 30 is what? Minus 5,000. That is the error for one record.
So all these diagnoses are done based on.
Hold on. So minus 25,000, that 5,000 is the gap in the prediction. Now in the test data set, if you have 100 records, for 100 values of error you will get. We take the total error and say that, boss, this is the total error of the test data set. If the total error is, let us say, very low, 1%, which means that whatever you have done at the training stage is a good thing. On the other hand, for every house, let us say there's a gap of 25,000, 60,000, 50,000, 1 lakh and such things, the total error will be also higher. Then you say that, boss, the percentage of error is 40%. Therefore, in the training stage, your model has not learned the characteristics. So you build the model of the training data set, then you apply it on the test data set. If you don't create the test data set, then what will you apply it on? You have nothing to apply. Test data set. Test data set. So far we are clear? So these are some of the things we'll just look at it. Okay. So shall we open up Python and start solving? Right now, even before that, I've just slightly taken up I would not say very complicated data set, but I felt that this would give you some kind of an exposure in handling the data and other things. Where is this? I'll share this data set with you. This data set right now is not with you. Just please bear with me. So this is the data set that I have. I'll just zoom this in so that you can see this better. Are you able to see this? So this is a typical telecommunication data set, but the principles, the ideas that we will be using will work on any data set. Okay. So what do you see here? So you have customer ID here, right? So this is not a very useful variable for modeling, right? If you have ID, Aadhaar card number, PIN code, right? Those things cannot be used for modeling, right? ID and says name of a person, phone number, those things are not very helpful for modeling. So I'll just color this in red because we have to actually remove this. Now look at these variables. You have variables like gender, and then you have variables like partner, dependent. I'm going to color this in yellow color so that you can just appreciate what we are talking about, correct? So all these things are categorical variables and they are string. They're character variable, right? Whatever, right? Then you have certain other variables. All these are service related variables like phone service and such things, which are again categorical variable. So you have gender, senior citizen, partner, whether he's living with a partner or not, dependent and tenure. Some of these are demographic variables and others are basically variables like phone service, multiple lines, internet service, online security, online backup, device protection, tech support, stream TV, yes or no, right? Stream movies. These are some of the services that he has bought or not. All these are marked as yes, no. Let me scroll to the right side. You'll see certain other variables like it's talking about contract month to month. Some of them are in the month.
It's kind of subscription.
Subscription basically. Others are paying at the end of 1 year, right? So on and so forth. 1 year subscription. Sorry, yeah, that's all right. The contract type is month to month or 1 year subscription or 2 years, whatever. Then you have paperless billing, yes or no. This again is a string data. Then payment method, if you see here, you have somebody is paying through electronic check, others are paying through mailed check, bank transfer, so on and so forth, right? All these variables are nothing but your string data. We have quite a few character variables, right? So many times, how do we handle this? This becomes a question. Next is basically some good variables are there, like senior citizen. This is not a big problem. So I'll just color code this as green. This fellow will also be in green because these are all scale variables or numeric variables. Then you have monthly charges, total charges. These are all green. I'm going to color this in green, right? So totally, what do you have? Just through manual inspection, I learned that there are 4 variables which are numeric variables. The rest of the variables in this data set are all categorical variables, right? My dependent variable, last variable that you see is nothing but the churn variable. That is the first person. If you look at the first two individuals, they are non-churners. Third guy is a churner. Fourth guy is a non-churner. Fifth guy is a churner, so on and so forth. Churn means basically people who have left, who have not subscribed, or who have, after subscribing, they have discontinued. Correct? So let me just simply apply a filter here. Yes. Yes, yes, yes. Yes, that's a categorical, but it's okay because it is numerical, 0, 1. Numerical. It is still categorical. What you're saying is right. Okay, so let me just apply a filter here and look at churn here. Do you see two categories? No versus yes. So we are trying to model whether a person has churned or not. And as you can see here, there are two categories, non-churners and churners. So this is a fit data set for us to try binary logistic regression model. Last class we had housing price. There the dependent variable was scale. Here we have basically a dependent variable which is not scale, which is a categorical variable. Correct? So I am going to use the last of the variables churn as the dependent variables. All the other variables except the variable customer ID will be my independent variables. And within this independent variables, I have two sets of variables. Some are basically categorical variables, and I have barely 4 numeric variables. So far, we are good with this. Now let me just close this. I need to find a way of sending this across to you guys. Just see if you can download in the chat. I've sent it, please. You're not logged into chat, is it? Okay, fine. I can just send it to your mail also if you want. I can send it to your mail if you want. AI04. Please tell me the mail ID. What is it? One of you can give me your ID. Or your group ID also you can give me so that I can just share it. I mean, shall I share it with you? You'll share. Amin R, right? This is the one, 19. So which one is that group? Just tell me the ID, please. Wait. AI04. Okay. Wait. Reva dot edu dot. Correct now? I think I've sent it to that ID.
Is it the same data? This one which we did, some different one. Where we have tied relation to
I think it's the same thing.
this one with logistics. Switch out.
I've sent it. I hope this is correct. AI04 at the rate reva.edu.in, right?
Is capital, I think.
Please tell me AI04.
AI04. AI is capital.
It should not matter. AI
AI04.
at the rate.
It's not for me, it's capital. For me, it's capital AI.
So tell me the ID, please, one of you.
At the rate reva dot edu dot in.
Of race.reva.edu.in. Correct? Is correct, sir? Race.reva.edu.in. This sending.
But for me, it's showing this one.
So for me, it's also.
It's for me, it's AI04 at the rate reva.edu.
So for me also, but it's AI is capital, I don't know.
Try sending on this. This is capital A, then I. 04.
Race.reva.edu.
Put A and I capital. Capital. Yeah, that one.
What is this? Come. We got it. Both chat anyway, it is there. Chat I've already sent it.
Chat, it is asking for access permission. Okay, I'll just copy this email. Send. I'm pasting that email in there. See, so that group.
aminar19@gmail.com.
No.
Wait. I'll send it to you. Send it. I don't know this. It is Aminar only, right?
Yeah.
Aminar19, right? Sure, right?
So it's AI04 at
That's right.
See if you have received it.
You logged in just now, no?
That's all.
I have it here. It's not downloaded.
That's what he sent.
Did you receive it?
I'll share it in that.
Someone can just reply to that email attachment. It's going, the mail is working.
I got it.
Yeah. I mean, do you have the data set?
I have, that's what I'm sharing with that.
Why don't you just reply to that email? And that's working.
It's slow. It's
The mail is.
attached. Yeah.
Something we put the data set on that in anonymous directory.
But I got it.
Inbox 3.
Yeah, this is the.
This one, right?
Everybody got the data set? Okay, shall we start? You start, sir, everybody? Okay, let us import some of the necessary packages. Let's begin by importing some of the necessary packages. Okay, I pasted this code in the chat. You can pick it up from the chat.
Yeah.
Sure, sure.
Then the real time you are not going to get such Excel or CSV file, right?
You can get any file, right?
Like in live, what will the major kind of?
Usually you may get it in the form of a database or something.
Is it directly?
You can connect to the database, pull the data result.
Can you say that?
Chat.
I just not know. You have to admit me.
It's in like in our company, we use PySpark to codes. Or like in AI,
What do you use?
PySpark.
PySpark. Okay.
So in AI, like in other company, we use PyCharm or we
So
say
PySpark. PySpark is if you have extremely large data set.
yeah, that like in AI, like in other company, what is a tool they are using? It's
Mostly, see PyCharm for image processing. If you are doing image processing, PyCharm comes into it. A lot of the times, image processing can be done in just in Keras or TensorFlow also. It's a lot easier.
But what are the tools in real time?
Read TensorFlow and Keras. Use TensorFlow and Keras, your job is done.
Any kind of like regression model.
Oh, is it? TensorFlow and Keras for deep learning, especially
Okay.
text processing, image processing, these sort of things can be done.
Because here what we are doing, it's not going to use it in real time.
Why will not? Why will not?
The coding, we are going to use the techniques and skills, but we are not going to use the Jupyter notebook.
Will be, how else will you code? Where else will you code? You will need Jupyter Notebook there also, right? Without Jupyter Notebook, nothing can be done. Even your TensorFlow Keras has to be installed here only in Jupyter Notebook.
Because I have a concern of data privacy. It's open.
No, if Jupyter Notebook is installed in your system, it will only be in your local machine, right? It will not go out anywhere. If you're using a company laptop and all, you will not be able to transfer. Or people may use AWS as a platform. Amazon themselves, cloud platform. There again, Jupyter Lab is accessible. Okay, this is clear, everybody. We'll come back to this. You've installed this, right? Now let's make a move on to the second piece of code. Okay, this we are already familiar. We are printing multiple lines of code here. It enables me to print multiple lines of code. This you can copy from the last. In a linear regression also, it was there. I pasted it in a. It will give all the things. Multiple statements will be printed.
If you don't use that, you can go to the last.
Yes, yes, yes.
Actually, I found one more method. You just use them with a comma.
With a comma. Okay, okay, okay.
They say variable x, y, z, and 1. X, y, z, right? Then we come to the
Okay, okay, okay.
yeah, x, comma, y, comma, z.
Okay, 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 okay.
Just happen to be by.
Okay, okay, fine, fine. Good learning. This is done, guys, everybody. Now we have to go into the stage of importing the file. Correct. I don't know where you have saved the file. So in my case, it is desktop. So I'm just using pd.read_csv as a function. C drive users days Mithun desktop statistics are sample files. Telco.csv. The same. I was talking about the book which has cartoons. Just cartoons, and that will help you understand concepts. I think you need this book, not that. Use this one. Okay, have you been able to import this data set, guys? You can see here the sample size is around 7043 and we have 21 columns. 21 columns and 7043. I don't know if I'm audible to everybody online. Jyoti NM.
Shashikala, Sandeep. Have we been able to? Huh? Oh, Sandeep, okay. Jyoti, she's part of AI, is it? Was she there in AI is 0? First 3 days, I don't think she was there. Okay, so far we are clear. We've imported the data set. So far, we have not done any analysis and such things. So from here, let us just proceed to do some kind of analysis. Let us begin by exploring the shape of the data set. So we can see here 7,043 records we have and 21 different columns we have, correct? Now, obviously, when you look at the type of the data set, is a pandas data frame. Size. Okay, here this is just giving you the cells. It's just taking a multiplication of 7043 into 21. TF dot size. Let's just print out the first 5 records. Correct? I think we have been able to pull out all the records. And if you want tail, we can just print out df dot tail as well, right? Okay. Now, the next thing that we need to do is basically we have to check for missing cases. Are there any missing cases or not? Firstly, when you check any, it just returns false. There are no missing cases. Then let me just take the sum. It just says 0, 0, 0, 0, 0. This can be slightly deceptive at times. In fact, not can be, it is deceptive. Yes. Okay, what does it say? Basically, 0, 0 means none of the variables have missing cases. It has 0 missing cases, correct? Right? 0, 0, 0 means there are no missing cases at all. Correct? Now, let me just take a look at this. I'll be basically applying a filter, data and filter. Right? Let me show you one of the variables, total charges. Do you see here? There are a few blanks here. You can see here, when I click on this particular variable and select blank cases, there are at least 8 blank cases. Sorry, 11 blank cases if I'm right, which is going undetected. Right? So there is a bit of a problem here with this pd.sum.null of. Correct? It is the moment it gets a blank case, it just treats it like another category. So it doesn't work well. So we have to find out. Yeah.
Not detecting as a null.
Data is present, yeah. So what we have to do is basically, we have to basically tell that this variable is a numeric variable and then rerun it. Because total charges that you saw is a numeric variable. How much you are paying, that is a numeric variable. So first what we will be doing is basically, we will basically data type of this df.info. Just do a df.info. It is treating total charges as an object variable. It is not an object variable at all. The word object in Python means what? It is string or categorical. It will be treated as string or categorical. Because of the presence of those missing cases, it is being treated as an object. In other words, Python perceives this particular variable as string. It is not string. Right? One more way of checking this is basically just run a describe function. Correct? Describe will give you all the summary statistics if you recall. Correct? Count, mean, standard deviation, minimum 25th percentiles and maximum. It is just giving you all these things for 3 variables: senior citizen, tenure and monthly charges. Are you able to get this for 3 variables? But ideally speaking, if you recall, I had colored 4 green variables and I've told you that there are at least 4 scale variables. The problem is that it is not able to. So describe works for what? Scale variables. Right? So it is not able to recognize, it is not displaying total charges at all because it is not reading this as a numeric variable, which is its original data type. Let us try to impute it, missing value imputation. Let us just try to do it. It will not work, but just that I'm showing you something. It will not work because it returns an error here, right? Because correct value error, it says, see, DF of total charges, I'm trying to fill it with mean value. It just gives me a error because by definition, mean and such things are applicable on numeric. But because of the presence of those blank cases, it is being read as an object, and an object it is not able to understand. So what I have to do is I have to grab the neck of this variable and coarse it. I have to forcefully treat this as a numeric variable. And then some of these things will work. So we'll be coarse. The word coarse basically means force. We are literally forcing this variable, right? So in the next step, what we will be doing, and this is very, very important, we will be converting this variable into a numeric data type. PD.to_numeric, right? So I am treating this df.total charges as a numeric variable. If there are errors, I'm just saying coarse.
And what the way
It just ignores, even if you get errors, it'll just ignore those missing cases. Otherwise, the first 100 records in numeric is a number. Missing case, it'll just return an error. How can I treat a string to numeric? That's the Python psychology.
So 2% will ignore, but those records will be removed from our.
Those records will be there, but the overall nature of the variable will be treated as numeric.
The blank values
Will be blank only. It will be just blank. What I will do is at a later stage, I will impute it with the mean. With mean.
Okay.
Earlier, the mean imputation did not work. It did not work because it was right. Because it was treated as an object. Now that which one?
These kind of cases.
Yes.
First I replace all the blank with NA, then converted that numeric and that. Then all NA I started with.
Okay. Yeah. So I'm just using the coarse method. Okay. So now that you have coursed it, some of the earlier commands now will run. All right. We have coursed this. What I'll now do is basically now let me go one step back and run the mean function. Now it will work because it's treated as a numeric variable. Let me go one step further back and run the describe, a new variable. Summary statistics for total charges will also pop up, right? Now, let me just pick up this df.info. See here, the last variable total charges is now being read as a float variable. This is good. I don't know whether people online are following me or is it too fast? Are you able to follow me, madam? Yes, okay. Am I too fast with the coding? I don't know. I just wanted to start the coding before lunch break, before breaking for lunch. Otherwise, okay. I'll anyway display this code for you. So far it is clear. It's actually 110 by the time we'll go, right? 120. After 130, we'll have problem. Shall we break for lunch? Shall we please break for lunch? Shall we be back by around 2:15? Shall we be back? We'll have lunch, we'll come back.